So that's how you want to play it, old man? No dessert? Oh, sure. We'll eat our dinner right after you eat this. Ah!
This homework is called Explain Statistics, and the idea is to see how comfortable you are with some of the most common statistics that we see and things you should have seen in the intro class. And let's explain these difficult things in terms that someone who is very young could understand. Let's take a look at it. And keep in mind, my version is going to look just a little bit different because I'm the instructor, and so this is a preview of how things look. But here's the idea. There's some words in bold that we're trying to define, and let's say that our target age was like an 8-year-old. How could we explain things? So for example, standard deviation. If you took the intro course, you probably used standard deviation. You may have calculated it. You may have a good idea of how it's used. Could you explain what those words standard deviation mean? And so I put down 5 answers. One of them is a good answer. The other 4 are common things that I hear students say, but there's something about them that's wrong. For example, saying how much TV you watch is going to be within 21 minutes sounds good, but that doesn't mean on average that's how far off they are, because when you calculate standard deviation, there's a squared average that is square rooted. So it doesn't quite come out the same as being an average. The second one is a common way to say it. There's an average amount, and the average amount has a standard deviation, which is variability. You really haven't explained anything. You've just gone in circles talking about it with the same words. Randomly chosen kindergarten, 21 minutes per day, less or more, but it's unusual to have 42 minutes per day, less or more. And that one is an example of not a bad way to try to talk about it. Some kindergartners have about 21 minutes more or less, or on rare occasions 42 minutes more or less. To get more complicated is probably going to lose an 8-year-old child. For example, the square root of the expected square deviations. Well, okay, that's true. You fix the problem with the very first example where it just said it's an average. Well, it's not exactly an average, it's a squared average. 8-year-olds aren't going to be able to follow this. Okay, this isn't going to be helpful. Here, all kindergartners have 21 minutes or less of television. Oh, I was about to say somebody said 21 minutes from the average, which would still be wrong. But here it's treating it almost like it's the average itself. So this is an example of a quiz where you go through, and the first time you read it, it should be that each one of the answers makes sense. And that's not weird. There's nothing wrong with you. That's why these are common things for people to say. And then as you go through and read them and really think about them, each one, it'll probably be that none of them look good. But look for the one that has no errors, actually explains what you want to know, and explains it in such a way that an 8-year-old could understand it. That's the one we want. And as you finish the quiz, the hope is you will be able to say, now I know the kinds of wording that I can use that make a little more sense to people. Keep in mind as you work on this that when you submit the quiz, you're submitting all of it, and it'll tell you which questions are right or wrong, but then to redo the quiz, it'll make you restart from the very beginning, which is really annoying. So often students will have an extra tab open where they're putting answers in that they know they've gotten right, until finally at the end you can submit the quiz with all of the correct answers. And since you have 99 tries, it is expected that you should be able to get the correct answers. All right, go to it, because there's probably some other homeworks also in this same chapter to work on.